Greetings, math fans. All right, so basically what we're doing today is day 5. We already talked about inequalities, graphing inequalities and how to solve them. And remember, when you divide by a negative, you switch the direction of the inequality. Okay, so this is, again, going to be day 5. And we're going to talk about something called compound inequalities. Okay, and so compound inequalities, it's kind of broken up into 2 days. Okay, so today we're going to concentrate on something called and or between problems. Tomorrow we're going to talk about or problems. Okay, so these are and between problems. Okay, one of the two. Okay, the key word here, math fans, so the key word is overlap. I just cannot stress enough. So think about it. Where the lines overlap, that is the answer. That's all I can tell you. Where the lines overlap, that is the answer. Okay, so let's just kind of start with an example here. I'm just going to literally draw a graph here. So here's a number line, and we're going to use just some basic numbers here, 5, 6, and 7. And I'm going to draw 2 graphs. So one's going to look like this with a solid dot, and one is going to be an open dot and look like this. Okay. So my question to you for this problem is, where do these lines overlap? Okay. Do you guys agree that these lines start to overlap here? Right, they're both in that location. So at that point, at 6, that's where it's to overlap. So what I want to do is, if I graph that, do you guys agree that it's going to be 5, 6, 7? So it starts to overlap at 6. And again, overlap just means where you see 2 lines. So it's overlapping here, right? All the way, it just keeps going. So starting at 6, it starts to overlap. So the graph of this is from 6. So this is really my answer right here for the graph. The answer, right, for the graph part. Okay, so do you guys agree that this is going to be x is greater than 6? You guys agree with that, right? Remember, it's whichever way this arrow points, that's also that inequality. Okay, it points that way. So x is greater than 6. So here's the deal. The problem will start out, let me just write out how the problem starts. It'll say x is greater than or equal to 5 and x is greater than 6. That's how the problem's going to start. Okay, so let me get rid of a couple of these things here. So what you're going to do is you're going to, given that information, you're going to draw this. Okay, which is easy. You did this yesterday. So you're going to say x is greater than or equal to 5. Draw it. You're going to say x is greater than 6, so an open dot, and like this. And then you're going to say, where do those lines start to overlap? Oh, starting at 6. So you're going to draw the solution graph. It's starting at greater than 6, and then you're going to write this out. Oh, you're going to look at the graph and go, oh, my answer is x is greater than 6. That's all you do. That's all it's about, guys. So you literally are going to graph these and then look to see where they start to overlap, and then you're going to draw the graph, and then you're going to answer it. So really, you got 2 things that you're going to give me. Okay, you're going to give me this graph right here, and you're going to give me the inequality. That's what you're going to do. Now this part right here, math fans, this part right here, that's the part that you're going to start out with it. That's like your work in progress. Okay, so this is like, see this stuff right here? That's what's going to be given. So if I had to literally label all this stuff here, you're given this stuff here. That's the first thing. You're going to do this first. You're going to graph that, and you're going to go, oh, let's see, they intersect at starting at 6. So this is the third thing you're going to do. And then the fourth thing you're going to do is you're going to look at this graph that you just, number 3 here, and you're going to say, oh, x is greater than 6, and you're going to be done with the problem. Okay? That's all you're going to do. All right, so a lot of writing here. So let's try another problem. Okay? Let's just start out with what you do. You would say x is less than or equal to 6 and x is less than or equal to 7. So you're going, this is given. So given, and the first thing you're going to do is you're going to draw a graph. So you got 6 and 7. And then what you're going to do is you're going to say, all right, less than or equal to 6, that's easy. And this one is less than or equal to 7. Both solid dots. Where does it start to overlap? Okay, where do you see that it starts to overlap? And if you guys notice, it starts to overlap right here, right? We're at 6. So you can see 2 lines here. So it starts to overlap at 6. So my graph is going to look like this. 6 and 7, and here it's going to start to overlap right here, and it's going to go out this way. Okay, that's the answer to the graph, and then on the answer blank, you're going to write down, you're going to look at this graph and go, oh, what does this graph represent? Oh, x is less than or equal to 6, and that's the answer to this problem. Okay, it's not bad, right? Pretty mellow. Okay, let's go for another one here. X is greater than or equal to 5, and x is less than 7. Okay, so the first thing you're going to do is you're going to graph it. So 5, 6, 7. So you're going to say greater than or equal to 5. And then you're going to say less than 7. All right, is that cool? Right, pretty easy. And then you're saying, now where do the graphs overlap? They overlap, right, starting here to keep going, here. Between there and there. It's basically between those, which actually kind of introduces me to another type of problem. This is called a between answer or between problem. So this is how you write a between answer. First of all, let me just graph it. My intersection is going to look like this. Between 5 and 5, 6, 7, and you're going to have a solid dot here and an open dot here, and this is where they intersect or where they overlap, where that green was. I just sketched that in. So it's going to, your answer is going to be between 5 and 7. This is how you write that out. You guys ready? It's very, very simple. Again, this is a between problem. So I'm going to write this out, between. Remember, that was one of the things, ands and between, which are kind of the same. Okay, so you're going to write it out. Watch closely. Here, we'll do it in green. So x is between. So see how this is a solid dot, and see how this is an open dot. So you notice the equal to sign and no equal to sign, and you're going to put a 5 here, which is there, and here a 7 on the other side. And this is the answer to this problem. It's between 5 and 7. Okay. Notice, guys, the arrows always point this way. Always, always, always. No matter what, inequality, whatever, they always, always, always point left. Okay. Always, always, always point left. Okay. So that is your answer. Okay. We're going to do a couple more of these, but just like a little more practice here. Okay. All right. Let's try another one here. X is less than or equal to 5, and x is greater than 7. Okay, so let's go ahead and graph it. 5, 6, 7, and it's less than or equal to 5, and greater than 7. Very interesting. Where do these graphs overlap? They don't. Not at all. They don't overlap at all. This one's going way out this way, and this one's going way out this way. There is no overlap. There's nothing in between here. There is no overlap. So if there's no overlap, my answer is no solution. Okay? So there's not even any graph. If there was a graph for you to graph, you would really just put a slash through it or leave it blank. It's nice to put something there, so I know you don't. If you leave it blank, sometimes people don't know what they're doing. So really, this is no solution to this problem. Okay, it's because they don't overlap. So those are the 4 different scenarios I just did. Are the only 4 scenarios that you can have here. All right. So let's do a couple more here. Again, I'm just going to kind of make these up off the top of my head here. I'm going to say x is greater than or equal to -1. And x is greater than 3. All right, well here it is, -1, 0, 1, 2, and 3. Okay, and so we graph it. X is greater than or equal to -1. And then X is greater than 3. Hey, where do they start to overlap? They start to overlap right here. That's where they start to overlap. So it's at greater than 3. So your answer, so if I graph it first at, let's see, we can just do 2 and 3. It's at 3, it starts to overlap. So your answer to this problem is X is greater than 3. Really not difficult, right? Overlap. Keep saying that word. Keep saying that word. Okay, let's try another one here. X is greater than 10 and X is less than or equal to 13. Okay, so let's graph it. 10, 11, 12, 13. Okay, so greater than 10, less than or equal to 13, solid dot. Okay, where do they overlap? Right, they overlap right here. So between, what? Did I use the word between? Okay, so I know what to use. If it's between, so let me draw a graph here. So it's basically between 10 and 13. And it's going to be an open dot and a solid dot. That's where it overlaps between these two. So that's your graph. And remember how you write it. You write it like this. You say X, and then this is an open dot right here. So less than, and this is a closed dot, less than or equal to. And remember, they always point to the left. Always, always, always. And then you just put it in there. There it is, 10 and 13, and you're done with the problem. Okay? Really not that bad. Okay, so those are all and problems. Let's actually do a couple more between problems, and just to kind of make sure you guys are good to go. Because between problems, not that they're challenging, but they might have a little bit more work. And actually, before we do that, I want to do one more and problem. And this is the reason I want to do the and problem, because you might have a little bit of work here. I might say 2x minus 3 is less than or equal to 11, and 5 minus x is greater than, we'll say 7. Okay, so what you have to do with this before you can even do anything to graph it, you have to solve. Each of these you have to solve, and then you do the and you kind of did what we just did in the past. Okay, so the first thing I can do is I got to add 3 to both sides. So I get 2x is less than or equal to 14 and divide by 2. So x is less than or equal to 7. And this one I'm going to subtract 5. So you get negative x is greater than 2, divide by negative 1. So x is less than negative 2. Okay? So it's x is less than or equal to 7, and x is less than negative 2. So you graph it. So here's negative 2, this is 0, and here's 7 out here. And so I'm going to graph this baby, less than or equal to 7, solid dot, going across, and less than 2 is an open dot going to the left. Okay, so let's come up with our answer. Do you guys agree that we are basically starting to overlap right here at negative 2? So your final answer is going to look like this. We're going to put negative 2 here, draw a couple other numbers, and it's an open dot, and it's going to the left. That's your graph. And your answer then is going to be x is less than negative 2. Okay? That's all it is. Pretty simple. I mean, you can get, there could be a between problem, you can be whatever, but that's what you do. You got to solve, and then you just deal with the and. Okay? All right, so let's do a couple between problems. We already know between what it looks like, right? If I have a between, so between is going to be x is less, like something like this. And you guys know, if I gave you a graph like that and I said, go ahead and graph it, you should know that you put basically a 3 here. So 3, we can go 3, 4, 5. And look at this, and that's a solid dot. here, and this one's a open dot here. It's between 3 and 5. So you draw your line. It's like a barbell. Okay, between 3 and 5. Okay, not bad. So let's make it a little bit more difficult problem. Not a big deal. What if I said x plus 3, and that's between 8 and 10, something like that. All right. So guys, you know how if I just gave you x plus 3 equals 10, you went, oh, well, I got to subtract 3, and so I get x equals 7. So here's the deal. We still need to solve for x. We're always solving for x. So solve for x. And so what I'm going to do is you see this is x plus 3, so I'm going to subtract 3 from here, but you got to do it not only on one side, like here I did only on one, obviously, or two sides here, but you got to do it on all three sides. So it's minus 3, and minus 3. So you get 5 less than or equal to x less than 7. That's how you do that. Okay? And so you go ahead and graph it between 5 and 7. And so this is going to be a solid dot, and this is going to be an open dot. And that's your answer. Okay? It's not bad, right? Okay, a little bit tougher. Not much tougher. If I did 2x minus 4, and that was between 6 and 10. All right, so it's kind of the same thing. I'm going to add 4 first. So I get 10 less than or equal to 2x less than 6. Okay, and then how do you get rid of that x? It's 2 times x. Just like if I had 2x equals 6, how do you get rid of the x? Divide by 2. So you get x is 3. So here I'm going to divide all 3 sides by 2. So you get 5 is less than or equal to x, which is less than 3. Hey, okay, that's the answer. And then if I graph it, what would I do here? Oh man, what the heck? I added. So this is supposed to be 14 here. Sorry. 14, so this is divided by 2. This should be 7. I knew there was something wrong here. And I could tell actually there was something wrong because you need to have a 5 here and a 7 on this side, right? Okay, so 5, 6, 7. So anyway, this is a solid dot here, and this is an open dot here. And you connect it. All right, and that's your graph. Sorry about that little mistake there. Make a mistake every once in a while. It's all good. Okay? As long as you learn from your mistakes, right? Okay. So I have one last between problem that actually gets a little challenging. So try not to cry too much. So here's the deal. If I did 5 is less than or equal to 3 minus 2x, which is less than, we'll go with 11. Okay, now this is a little challenging, and remember I told you when you graph a between problem, the arrows are always going to point this way. They're always going to point to the left. Okay, just keep that in mind. Keep that in mind. So the first thing I'm going to do, just like if I said 3 minus 2x equals 11, what's the first thing you're going to do is you're going to subtract 3 from both sides, right? So that means I'm going to subtract 3 from all sides. So I get 5 minus 3 is 2, less than or equal to negative 2x, less than 8. Everybody okay with that? Okay. I think I subtracted right this time. Okay, and then what are you going to do? You're going to divide by negative 2. So like just if I finish this one, it would be negative 2x is equal to 8, right? And then I divide by negative 2. Everybody okay with that? So I'm going to divide everything by negative 2. And what happens when you divide by negative? You switch around the inequality sign. So it's going to be negative 1 greater than or equal to x greater than negative 4. Now here's the deal. These inequality signs are pointing the wrong way. In fact, if I tried to graph this, you would go, oh, negative 1 and negative 4. And that's actually not right. Because you don't, negative 1 is certainly not in the left, to the left of negative 4. It's always this way, right? Negative 4 and negative 1. Because negative 4 is more negative. It belongs more to the left. So remember, when you divide by a negative, you switch around the inequality, which we did. But then we need to rewrite this. We need to rewrite this where this number's on the other side now, on the left side, and this number is on the right. Okay, so I'm going to put a -4 here, and I'm going to put a -1 here, I'm going to put the x here, and I'm just going to switch around the inequalities. Now, I want to point out one thing, math fans. See how this one's pointing to the -4? Keep it pointing to the -4. And see how this one's pointing to the x? Keep it pointing to the x. You didn't change it at all. Okay, so if I took this and I literally flipped it, I can't show you on the computer. If I literally flipped that equation, so flipping this would basically, all the arrows would point the other way and the numbers would point the other way if I completely flipped it. And that's exactly what it looks like. The arrows are pointing the other way and the numbers are also pointing the other way. Okay? So if I go ahead and graph this thing now, and move it down here, if I go ahead and graph this, I'm going to get -4, -3, -2, -1, and it's between -4 and -1. So I'm going to put an open dot here and a solid dot here, and that's my answer. Okay, between -4 and -1. All right, so that's the only tricky one, and it's only when you divide by negative you flip that around. Okay, so again, if you divide and your arrows are pointing this way, you need to change that whole thing around, because you cannot graph it if the arrows are pointing that way. The only way you can graph it is when the arrows are pointing this way. Okay, so that's basically it for between problems and for and problems. And like I said, tomorrow we'll go with or problems. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.